Alright, so in this section, we will be exploring the family of the second-degree binomials, which we call the quadratic function. While there are many characteristics of a binomial in general, the calculation involved in working with quadratic is typically very simple. Now here, notice that we have two kind of forms of a quadratic equation. The standard form of a quadratic equation, which has the form of f of x equals ax squared plus bx plus c. And also we have another form, which is the transformation form, which has the form of f of x equals a times x minus h to the power of 2 plus k. Now, if we take the transformation form of the equation, f of x is equal to ax minus h squared plus k, and we expand this equation, we will have ax squared minus 2ahx plus ah squared plus k. Now we notice that this right here is the expanded form of the transformation form of the quadratic equation. And we know that the standard form and transformation form are two equations that are equivalent, meaning they're equal to each other in value. So I'm going to take the expanded form of my transformation and I'm going to set it equal to the standard form of the equation, which is ax squared plus bx plus c. Since both of these equations are equal to each other, I know that the coefficient in front of the variables have to be equal. They have to be the same value. So a is equal to a and negative 2ah has to be equal to b. Now I am going to take the coefficients in front of the x variable and I'm going to set it equal to each other. So negative 2ah is equal to b. And I am going to solve for h in this right here. So here I will have h is equal to negative b over 2a. The reason I am solving for h right here, because using this fact over here, I can go from any standard form equation to a vertex equation by finding my h value. So right here, I'm going to write my transformation form. F of x is equal to a x minus h squared plus k. So my h value right here, I can use the fact that h is equal to negative b over 2a to find my h value. And my k value is found by doing f of h, meaning taking that h value and plug it back into the equation, and whatever that value is, it's going to be your k value. So if I wrote my vertex form, f of x is equal to ax minus h squared plus k, I know the value of h and k. If I wrote them in point form, h comma k is the vertex of my quadratic function. What we mean by the vertex is having a parabola. It's the lowest or highest point on the parabola, which right here is this. It's where my parabola goes from an decreasing to an increasing. So that point right here is what we call vertex, and it has the form of h comma k. Where right here, h is going to be found by using the equation negative b over 2a, and the k value is found by plugging in h back into the function. So right here, I have the equation f of x is equal to 2x squared minus 12x plus 14. So this equation is in standard form, and we want to write it in a transformation form or in vertex form. So right here, the first thing I'm going to identify, my a is equal to 2, my b is equal to negative 12. And now for my c value, I really don't care about because I'm not going to have any use for it now. So here, to write it in vertex form, I need my h value, which we know that we can find it by doing the equation negative b over 2a. So my h value is, my b is negative 12, so negative 12 over 2 times 2. So that gives you a negative and a negative, positive 12 over 4. 12 divided by 4 is equal to 3. So my h value right here is equal to 3. Now to find my k, I basically just take my h value and plug it into the function. So I need to find f of 3. So taking my standard form function for every x I see, I am going to plug in a 3. So 2 times 3 squared minus 12 times 3 plus 14. That is equal to 2 times 9 minus 36. 14 equal to 18 minus 36 plus 14. That is equal. So now here my k value is equal to negative 4. So now to write it in my vertex form equation, I know I am going to have an equation that has the form of f of x is equal to a x minus h squared plus k. Now I have my h value and I have my k value. I identify them. My a value I am going to obtain from my standard form equation because that's value not going to change. Now here I'm ready to write my standard form equation in vertex form, which is going to be f of x is equal to 2 x minus 3 squared minus 4, where here my vertex or my lowest or highest point of the quadratic equation is going to be 3 comma negative 4. Now another way to write a standard form quadratic equation in its vertex form is by completing the square. So right here I have the same function we worked on from the previous example, and now I'm going to rewrite it in vertex form by completing the square. So the first thing I'm going to do right here is, in order to use the completing the square, my a value has to be a 1. So I am going to factor out a 2 from this function. So that gives me x2 times x squared minus 6x plus 7. And now I'm going to set the equation equal to 0. So now right here, I am going to take whatever inside the parentheses, which is x squared minus 6x plus 7 equal to 0. And I'm going to complete the square right here. So the first thing in completing the square is I take my c value and I move it to the other side of the equation. So I would have x squared minus 6x equal to negative 7. So now I take my b value, which right here, b is equal to negative 6. So I take my b value and I divide it by 2. And whatever I obtain, I do it to the power of 2. So here my p value is negative 6 divided by 2 squared is equal to negative 3 squared, which is equal to 9. So now right here, I am going to add 9 to both sides of the equation equals negative 7 plus 9. So now here, notice that the left-hand side right of the equation, I can rewrite it as x minus 3 squared and negative 7 plus 9 is equal to 2. So now my last step right here is I'm going to take the 2 and I'm going to write it on the other side of the equation. Minus 2 is equal to 0. So whatever I obtain right here is going to go into the parentheses because this x minus 3 squared minus 2 is just whatever inside of the parentheses. So from here, I'm going to have 2 times whatever I obtain right here, which is x minus 3 squared minus 2. And now I am just going to factor, I'm going to put this 2 inside of each term of my parentheses, get rid of that parenthesis. So that gives me 2x minus 3 squared minus 4. And notice that this answer is exactly what we got from our previous solution.